Okay, so we're going to do kind of a quick one, I suppose, hopefully, on working with your right angle triangles and kind of the tools that we have to use that. So we basically have, I suppose, two different tools, if you like, in a general sense that are possible or that we can use with right angle triangles. Those being Pythagoras' theorem, or the theorem of Pythagoras, and your trigonometric ratios, okay? And obviously then within the ratios, we have three of those that we can use. And all of these tools, I suppose, are kind of available to us as we work through these various right angle questions. So what we want to work on now really is just applying those rules and knowing when to apply which, and then how can we use that then to find whatever it is that we're looking for, whether it be a missing angle or a missing side. So the main thing, first of all, is going to be identifying which is missing, so whether it is angle or side, labeling my triangle with reference to the information that I do have, deciding which ratio to use based on that information. So generally, I suppose, with a right angle triangle question, we would expect that at some point we would come down to needing to use a ratio, particularly if angles are involved. Pythagoras, I suppose, primarily used where it's only sides, and then we would solve for whatever the unknown value is. So looking at, I suppose, these first two examples here, I have one with a missing side, I have one with a missing angle. So we'll start on the left here with missing a side, calculate the value of the side marked x, giving your answer to two decimal places. So we can see from my triangle here, the side x is the side BC to the right hand side here, so that's this side here. And I also have information about some of the other sides. So I know side AB, for example, there is 10 centimeters, and I know the angle CAB or angle A there is 30 degrees. So I have a good bit of information available to me here. Now, since I'm looking for a missing side, I suppose I'm going to label my triangle with reference to that. Okay, I'm starting with the angle that I know here, which is the 30 degrees, and I'm going to label everything with respect or relative to that angle. So the first one always that I would nearly start with is the opposite, which is the one that's across from the angle, and that's actually going to be x in this case. So x is my opposite side here. The next one, I suppose, that is usually the best to go for would be the hypotenuse, and the hypotenuse is the longest side, and the reason I'm marking in the right angle here is because it's always across from the right angle, because the biggest side will always be opposite the biggest angle in a triangle here. And the last one then that we can label, I suppose, by process of elimination somewhat, is the adjacent side. This is the one that is beside the angle that you're talking about, so the 10 centimeters here. So because in this question I am looking at opposite and adjacent, and because of the information that I have, which is a side and an angle, I know I'm leaning towards a trig ratio, and the ratio I'm going to be using would be tan here. And we can work that out, I suppose, by looking at our SOHCAHTOA. So if I list out my SOHCAHTOA here for myself, that just tells me which of the sides I can use. The one I know is adjacent, so that rules out sine straight away, so I know that I'm between cos and tan, and the one I want is opposite, so therefore I'm going to go for tan. So to start myself off, I'm just going to start by writing out this ratio, so tan of an angle is opposite over adjacent. In this question, I know the angle is 30 degrees, I know the opposite is x, and I know the adjacent side is 10. So let's fill all of that in. So tan 30 is x over 10. Now, since I'm solving for x here, I want to isolate x or get it on its own. So that might mean multiplying both sides by 10 here. So that's going to give me 10 tan 30 equals x. So we no longer have a fraction on the right hand side. I can then work out the value of this 10 tan 30 here. So let's do so. And that is going to give me an answer of 10 root 3 over 3. But was I asked for anything in decimal to two decimal places? So in decimal places here, we can go for 5.7735, which to two decimal places will round to about 5.77. And we were given any units, centimeters. Okay, so using our ratio there, filling in our information as provided to us. We look at the right hand side here, which is looking for a missing angle this time. So we know we have to use this angle, so therefore once again we will label everything relative to that angle. So I'm going to start with my opposite side here, which I'm filling in as BC. I'll go for my hypotenuse next, which I know is across from my right angle, so that's the 10. And lastly, my adjacent side here is 8. This time I want to use hypotenuse and adjacent, so if we go back over here to where we had our SOHCAHTOA, the one that includes A and H is going to be cos this time. So again, I'll start by just listing out cos A, which is adjacent over hypotenuse. I'm building up some marks here as I go. My next way to ensure I get some marks is to fill in some answers. My angle is the one I don't know, that's theta. My adjacent side I do know, that's 8, and my hypotenuse I also do know, that's 10. So let's fill in all of this information that we can here. 8 over 10. Okay, so we're coming to an interesting one here where we have to use a slightly different version of some of these rules here. So we want to isolate theta, which is the angle here, and at the minute what I would need to remove to do that would be the cos. So I'm going to have to, as we've done in the previous question, we used the opposite operation here, or the inverse operation. We're going to use the same thing here. So we're going to use what we call the inverse cosine function, or cos inverse, which is cos minus 1 8 over 10. Okay, but I suppose it's said as cos inverse, and let me actually change the size of that pen there because it's a little too difficult to read. So cos inverse of 8 over 10. So the reason we're using the cos inverse here is because we want to eliminate the cosine function there, the cos function in front of my angle. So I can do this on my calculator. Usually it would be just above the original cosine button or cos button there, and you should see that it is here indeed. Cos inverse of 8 over 10 gives me 36.8699, and I was told to the nearest degree, so to the nearest degree would be 37 degrees for theta here. So we've seen some two good examples there, I suppose, of how we can use our just kind of usual rules, kind of the bare rules, and also then how we can use our cos inverse, for example, and all of these other functions as well within that. So we'll look at another example here, but a tiny bit longer. Find the value of the angle ACB marked theta to the nearest degree. Okay, so let's look at this first. Calculate the length of BC and then calculate BC using another method. Okay, so we'll work through it step by step. So find the value of the angle ACB marked theta. So first of all, I'm going to label my triangle. Let me see, this is going to go off on me, so I'm just going to pause here. So find the value of the angle ACB marked theta to the nearest degree. So let's just mark in the angle here. It's this, I suppose one of the sides here is this side 5. So I'm going to start labeling my triangle. Sorry, is what I was trying to say there. So that's going to be opposite. We'll go for hypotenuse next, which is going to be my 13 here. And lastly, my adjacent side, which is my side over here, my side BC. So I'm looking for the angle here. So I want that to be the unknown, which means everything else must be known in the equation. So therefore, I need to use one of my trig ratios. This time, because it's opposite and hypotenuse that are my two values that I do know, that's leading me towards sine as the function that I could use here. So if I start with this, sine of my angle is always opposite over hypotenuse. And remembering that these are just ratios, ways of comparing the sides in certain triangles. So we can fill in or identify what information we do know. We know the angle in question here is theta. We know that the opposite to that angle is 5. And we know the hypotenuse for this triangle is 13. So let's fill in all of that information, 5 over 13, and we can use now again our sine inverse function to work out the value of this angle here. Okay, I know I need to do that because I would like to eliminate the sine part here and isolate theta, the angle. So let's do that now. So sine inverse 5 over 13 is 22.61986. but it was to the nearest degree, so 23 degrees there. If we go to part 2, calculate the length of BC using a trigonometric ratio. So looking at what I have here and the options that I have available to me, I only have one angle that I can use in any of these trig ratios, and that's the angle we just worked out, angle C. Okay, actually to fully finish off that question, let's just make that really explicit. So the size of angle ACB is 23 degrees. So we know we can use that angle. We can use then any of the two sides that we know. We're looking for the adjacent, which means we have the, I suppose, ability to either use cosine or to use tan. Either of the two will work here. I'm maybe going to go for, I'm going to go for tan, just to actually show us a slightly different version of the problem here of answering these questions. So you could equally use cosine just as easily here. But I want to just, I suppose, get us in a certain scenario just so we can see how we would kind of deal with that one as well. So tan A is opposite over adjacent. Let's fill out what we know. We know the angle here is 23 degrees. We know the opposite is 5. And the adjacent is what we don't know, and we'll call it x. Okay, and remembering here, A is an angle, always has to be tan of an angle, sine of an angle. So let's fill in what we can. Tan of 25 should be 5 over something. Now here, I would like to isolate x, but ideally get it on its own on the kind of top line is what I consider it, nearly kind of on the main line of the equation. So let's multiply both sides by x here. That's going to give me x tan 25 equals 5. I could work out what tan 25 is here, but I also don't have to. Again, because I want to get x on its own, I'm going to need to eliminate anything else that is kind of around it. And the main thing I can see there is the tan 25. So we're going to divide both sides by tan 25. Okay, remembering that it is just a number. I just haven't worked out its value yet, but it is still just a number, so it follows the same rules and it can be multiplied or divided. So we get 5 over tan 25, which I can fill into my calculator quite easily, and that gives me an answer of 10.722. Now let me see, excuse me, not 25, 23. That's my fault for my messy writing here. 23. Let me just fix that up very quickly. 23, and let's change that up there also. And there we go, much better. Okay, 11.7793, but to the nearest, we weren't given any advice on this one, but let's go to the nearest centimeter for 12 centimeters here. The last part 3, said find it in any other way. So what I might choose to do for that one then is to go for Pythagoras' theorem. Okay, because that doesn't actually require me to use any angle or trigonometric ratio here. It does simply require me to label my triangle using the CAB idea. So let me fill in what I can. I know this is 5. We knew this was 13. We're unsure of this one. Let's fill in what we can. C is always the hypotenuse. A and B are interchangeable. I'm going to say that's A and we'll say that's B. So let's fill in what we can here. So 13 squared is 5 squared plus x squared, 169.25 plus x squared. X squared equals 144, which means x is the square root of 144. Sorry, I'm skipping steps. Square root of 144, which is 12 centimeters, as we worked out by our other method there. So just, I suppose, 2 examples there that show us some good, I suppose, give us an insight into all of the various ways you could use these ratios in different questions, and I suppose that they can help us then in solving some of these questions on unknowns. And really, I suppose, if you continue into some of those exam questions there, using those as your practice, you're just going to be using or utilizing a lot of that then in answering those questions, whether it be the standard ratios, Pythagoras, or even the inverse ratios there if we're looking for angles.